All right, here we are again. Today we're talking about neuroplasticity or plasticity in our brain. And to start off, so we understand what we're talking about the brain being plastic. And that isn't necessarily like your Tupperware plastic. It means that it's moldable, changeable, much like you could with plastic. You make just about anything, any shape, anytime, anywhere. Same goes for your brain. Your brain is moldable, adjustable, adaptable. And with localization, as we've kind of alluded to, it can be changed. You can move localization to places that are not originally designed to house them. So some things that we're going to look at in this bit of slides. Do adult humans develop new neurons? Right? You've heard the saying, can't teach an old dog new tricks. Well, is that true? What evidence do we have that adult brains are plastic or malleable? Let's find out. We've heard a little bit about Phineas Gage, so we've got some ideas. How does experience shape the brain, right? So what does the things that we do, see, feel, impact those transmissions in our brain, the plasticity? So exactly what is it, right? So neuroplasticity or plasticity defined lifelong ability of the brain to reorganize neural pathways based on experience. So what that means is, as we go through life, our ability to recall information, code it, store it, use it, changes. Those neurons that are used to send those messages change. They adapt, they get stronger, they get pruned, they go away. Okay? So some interesting things to know about it. Okay? There's different processes that are taking place, right? Proliferation, migration, differentiation. So proliferation, early on in our lives, we've got a whole lot of neurotransmitters, a whole lot of neurons in our brains to expand upon and learn new things, okay? To create these stronger pathways. We need to start with a lot so that we can take in a lot of information and make sense of it. Migration, you learn different things as you move on, right? For instance, in history class, early on when you were young, you probably learned Christopher Columbus was this great explorer that, essentially landed in America and started our country. Well, as you grew up, you knew that that is not accurate. So your understanding, those neurons connecting to your understanding, have migrated, they've changed. And differentiation, being able to tell different ones apart. Okay, maybe one sensation versus another, one sound versus another. Okay, how many times have you heard just the first couple intro beats into a song and we're like, yeah, I know exactly what that is? That's what's happening. Neuroplasticity, clear age dependent. Okay? Neurogenesis, when we're young, we have lots and lots and lots, as we mentioned, and lots of neurons, and they're being created and added on to all the time, fast rate. As we age and we learn and master new things, we prune, meaning we get rid of neurons that we don't need to make the ones that we do have stronger and faster. There's also two different conditions in which we exhibit plasticity. Sensory intake, learning, memory, stuff we're doing in school, okay? Learning a new skill. If you're asked to learn a new play in a sport or learn a new piece of sheet music, okay? And brain damage, adaptive recovery. If you have a concussion, you have brain damage, and your brain will alter itself based upon the damaged areas to be able to function properly. As we heard about with Phineas Gage, and you saw, took a railroad spike through the head. Brain adapts to that. So when you have injuries, your brain has to adapt. Maybe they move some language structure to a different place. Maybe they move some visual recognition to a different place in your brain. Okay, it will always kind of find areas that are not as dense to take up. Okay? And also your environment plays a key role. So if we think about development, right? If we think about young brains, the environment plays such a key role in how your brain is shaped and developed. Were you in a household that had a lot of books? Parents read to them. A lot of language, a lot of games to help develop all those neurons so that you start out life with more strong connections, or vice versa. Okay? and also the environment when you're older. Imagine somebody coming out of a prison environment back out into modern society. The rules and the social structure is much different. They're hardwired, if you think of it that way, as strong neural pathways on how to survive in there versus what we do out here. So let's talk about pruning real quick. Pruning, yes, is a term used for plants and trees and people who want to be florists and so on. But what happens in our brain isn't necessarily like lopping it off with a pair of pruning shears, but over time, as we strengthen certain connections, our bodies, primarily when we're sleeping, which is, again, we'll get to this, but is a really important reason why we need to sleep a lot, will trim off the ones that are not as important. Okay, so that way, we're able to be faster, more effective, more efficient in our brains, being able to process information. So you can take a look at the trees, right, with how it works. And you see how the top tree, right, the top tree is bigger, thicker, right? The other tree at the bottom that has not been pruned correctly, it wastes a lot of energy, wastes a lot of energy on those other ancillary small branches. Okay? Instead of growing up and growing thick, it grows bushy and shorter. Okay? Same thing's going on in our brain. If we don't prune it out, we can get confused, we can get distracted, right? So think about disorders that you could do research, further research to kind of figure out reasoning, causation, correlation, things like ADHD. Imagine, especially those of you that may have ADHD and the complexity at which it takes for you to be able to focus on something. Well, look at the bottom tree and all the different branches where it's difficult to narrow in what it is you're looking at versus the top one. Is there a correlation there? I don't know. Could be a really cool study for somebody to do sometime. So how do we know that this is going on? We'll read about this in our 40 studies for this week. There's a couple, I think you have two choices, but one of them talks about experiences in bigger brains. If this is the case, if you learn through experience and you grow new neural pathways this way, the more things you do, your brain should just grow out of its skull and explode. It should be huge. That's not the case. So how does that happen? How do we continue to gain more information, more skills, more mastery, and the brain stays the same size? Awesome study on London taxi cab drivers, and we'll spend some time talking about this here at the back end. But the London taxi cab driver exam is one of the most grueling, challenging mental examinations in the world. We'll talk about it here in a second. While it's under attack from things like GPS at this point, how are they able to perform on that exam, right? Where it takes years and years of experience to be able to master it. Okay. And hemispherectomies, being able to lose, alter, or separate brain hemispheres. Understanding, as we've talked about in earlier note sections, how our brains communicate laterally across both sections almost all the time. Well, what happens if that connection is gone or severed? Well, the brain has to adapt to it and be able to create almost two different working structures. Okay, so we talked about the taxi cab drivers, right? So we'll get back to them here in just a second. So we've got the different areas of the brain, and we talked about how do you get more in there? It gets denser. It doesn't get bigger. It gets thicker. It gets stronger. So if you're looking at the taxi cab drivers who have to memorize the entire map of London, right? That was the very first slide, was part of the map of London. So it's literally thousands of possible routes through the city, side streets, back streets, main streets, locations of businesses. It is intense. Okay? So when looking at them and doing the research, we found some interesting stuff. That posterior hippocampi was denser to those that had not prepared for this. The anterior region was denser than the others. Okay. Or it was opposite. The anterior was different than the taxicab drivers. My apologies. And the hippocampal volume, right, was correlated with the amount of time spent as a taxicab driver. Okay. Positively in the posterior and negatively in the anterior. So that they were better at the certain things that they had been training for in those certain regions. It showed it. And in the regions that they neglected was weaker. Why? Because pruning. They didn't use it as much. They didn't need it. Okay. So there's a capacity for local plastic change in the structural adaptation of the brain, depending on what the demands are, what they need to do. So because they needed to know this and needed to practice it, it got denser. And other areas that were not involved in this, to make space, to make availability, they got pruned. Kind of cool stuff. So that is pruning in a nutshell. We'll talk more about it when we get to, as I mentioned, stuff like sleep, development, memory, all of that. This will come back up. Okay. So it's a really cool thing to be able to understand.